Hello, my name is Kaiser from NOFFZ Technologies. In this video, I would like to introduce the Universal Wireless Tester. NOFFZ and National Instruments partnered to create a truly flexible RF instrument for testing wireless communication devices such as automotive infotainment systems, e-call modules, smart antennas, Wi-Fi routers and Bluetooth dongles, smartphones and many more. We are adopting testing needs for everything that goes wireless, from self-driving vehicles through smart homes to the industrial Internet of Things. Let's take a closer look. As new wireless technologies such as 5G New Radio, wireless LAN, 802.11ax or Bluetooth Low Energy are increasingly used across multiple industries, test strategies need to be adjusted. There is a demand from the world of IoT devices for high channel count test solutions. On the other hand, there is the need to employ the latest technology to support self-driving vehicles with 5G radios and car-to-car communication interfaces. The essence of these requirements is flexibility, scalability, and long-term support. Our concept separates the transceiver side of the system from the RF front end, slightly changing the way of thinking when engineers select RF measurement instrumentation. On the front-end side, we always need to think about how many antenna ports will require any type of RF measurements. For example, if the client wants to test smartphones, we need to consider at least 2 ports for cellular link, another 2 ports for wireless LAN, plus GNSS, Bluetooth, NFC, and maybe even FM radio. So we can easily end up in the range of 8 ports on a single device, with a growing tendency. In a typical manufacturing test setup, it's common to design test fixtures for 4 devices tested in parallel, summing up to 32 ports. So, how about the transceiver side? How many real analyzers and generators can we add to the system? That is the cost driving factor, influencing test time, yet in most of the cases, we cannot decide. We buy instruments where the number of transceivers is strictly tied to the number of RF ports. This is where the UWT wants to break the habit. We allow to configure the RF port count independently from the transceiver count. The system is designed in a way to add and remove transceivers from the test rack, like we're upgrading PCs with memory modules. If someone needs higher throughput, in other words, better test time, it is easy to add an extra analyzer and generator to the system. The system will automatically detect and use any new analyzers. The way of operation is similar to a typical client-server architecture. Measurement requests on a given RF port are the clients, the analyzers and generators in the background are the servers. The measurement and playback requests are arriving to the server at any time, and the server starts looking for an available analyzer or generator to match it to the request. With this approach, we can add new transceivers to our server to decrease test time, simply by empowering our RF instrument with extra resources. If the transceiver is not occupied all the time, we can decide to take it out of the test station and use it in another test cell which requires higher throughput. One can build test systems in many possible combinations of RF ports and transceivers, from a simple, focused one-to-one setup to a high-throughput 8-to-64 arrangement and beyond. This is our approach to building a universal test platform for wireless test challenges of today and tomorrow. We're very happy to discuss your requirements and ideas how to configure a UWT for your project. You can reach us at noffz.com. Thank you for your attention.